Okay, so guys, we'll get started with 5D. So 5D is quite a challenging exercise, but I'll point out not all of the stuff is sort of relevant, so I might make a list of questions you definitely need to do and encourage you to do the rest towards the end. So let's get into the examples. We're going to do this one together. This introduces you to the idea, and then we'll work through a previous exam question. And so when I ask a question from 5D in the test, it's going to be reasonably similar to something like this, okay? And you'll see quite a few of these kinds of questions pop up in previous tests, as well as here. There's two of them to go through. So let's get started on the first one. The only thing to say that we've got here, all right, is if we have f dash of t, right? Remember, f dash of t describes some rate, all right? It's the rate at which f of t changes, right? It's the rate. So if this is the rate function, all right, if we start with the rate function and we integrate it, then the function that we get, f of t, is the quantity function. So we go from a rate to some quantity, all right? So think back to abscissa calculus. The example in our test that we had was daylight hours, all right? Daylight hours throughout the year being periodic, okay? And then we differentiated it to get the rate at which daylight hours are changing, all right? What we're doing today is we're starting with a rate function and going back to a quantity. All right, so let's get into it. We've got a whole meal sandwich, delicious. It's eaten and converted to energy at a rate of. So we're given a rate function, all right? The rate at which energy changes with regards to time, dE on dt, is 250 times 1 on t, all right? Kilojoules per minute. And t minutes after the sandwich is consumed. It's valid over the interval 1 from t to 181. That's because you don't start consuming the energy straight away. It gets released it starts slowly being released after a minute. Find the integral from 1 to 121 of dE on dt. All right. So it wants us to perform the integral of this from 1 to 121. Or 250 times 1 on t. All right. So let's evaluate that. $250 ln of 121. I'm going to put it in my calculator. And we've got 1198.9, 1199 kilojoules. Just reiterate, ln of 1 is 0. All right, so that's always going to go to 0. So what does it mean? Okay, what have we done? F of t is the quantity function, and we've done the quantity from 1 to 121 minutes. This is how much energy is released over the first 2 hours, or after the first 2 hours of having eaten a sandwich. So 1,199 kilojoules. So almost 1,200 kilojoules are released 2 hours after eating the salmon. All right, on to part B. Find E of t exactly. So, if this is dE on dt function, then the E of t function is the integral of this one, right? So E of t is the integral of dE on dt. All right, which is going to be 250 ln of t plus c All right, it wants us to find E of t exactly, given that E of E squared okay, so what have I done there? All right, we're told when you put E squared into this function, the value is 550. So I've put my 550 here, I've put my E squared where the t is, and now we're going to just evaluate that for C. All right, so I'll keep my 550 over here. Here we've got 250 times ln of E squared simplifies to 2. ln of E to the x is x, so ln of E to the 2 is 2. And we have this plus C hanging out, 500. We've got C is 50. All right, so that's going to be our function. All right, that describes the quantity for any value of time. So that's going to tell you how much energy is consumed per part of time. All right, on to the next question then. Now this might be one I'll try project a bit as well. Projector and that working. So let's have a read of it. We've got 12-hour music festival. Starts at 12 noon and finishes at 12 midnight. The rate DE on DT at which patrons entered the venue over the 12 hours can be modelled by this function. So DE on DT, we have a rate function, and we're given the domain on which to graph it over. It's even presented to us below. Before 12 noon, there were no patrons inside the venue. The graph of DE on DT is shown below. All right, so this is going to be a good opportunity for me to go over some of the graphics calculator skills. All right, so I'm going to bring it up. You guys pull your graphics calculators out as well, and let's have a graph of it. I'm going to do it on both Desmos and my graphics calculator. Ow. Desmos. And Vivi, that's my code up there today, 931H. All right, so punch it in, we've got 220T e to the minus 0.4x, and then plus 15. And then for your V window, you've got y going from 0 to 220. It's better. $93.18. Okay. So, let's start answering these questions then. We've got it, we're ready to answer it. Find the rate at which patrons entered the venue at 12 noon. Okay, so this is the rate function. All right, what we've got, 220 t e to the minus 0.4 t plus 15. This is the rate function. Now we want to know the rate at which they're entering at 12 noon. 12 noon is when t is 0. So we're substituting t is 0 into this equation. Or we're just g solving what's the y value when x is 0. Alright, on the y-axis we have the rate, on the x-axis we have time. We want to know the rate when time is 0. So when t is 0, dE on dt is, all right, it's going to correspond with the y-intercept as well, 15. Okay, so the rate is 15, and what's the unit? Well, on the y-axis we have patrons, and on the x-axis time, patrons per hour. All right, so when time is 0, they're initially coming in at 15 patrons per hour. All right, use your calculator, find the time when the rate at which patrons entered the venue was a maximum. So that's just a good old G-solve max, one of these in the test. All right, we've got T is 2.5. So it's asking for the time, right? When T is 2.5, that's 2.5 hours after 12 noon. What's that? 2:30 p.m. Okay, the model implies that patrons continuously entered the venue. Identify the characteristic of the model that reflects this. Okay, this is a rate function, all right? It's the rate at which something is changing, and notice how it is completely above the x-axis. It is always positive. The rate is always positive, which means people are always coming into the venue. So to answer part C, like you can write it like that. You can say the rate is always positive. The way to write that mathematically would be dE of dt is greater than 0 for 0 is less than t is less than 12. All right, so they've restricted the domain, and over that interval we can see it's positive. Because it's positive, people are always coming in. Okay, on the graph, provide a representation of the number of patrons that the model implies entered between 1 and 4 p.m. Between 1 and 4 p.m. So that's when time is 1 to time is 4. So what we're doing then is we need to represent that on the graph. So if this is a rate function, then the way we represent it is by shading, all right? The area under the graph represents the quantity. Think about kinematics as another way of confirming it, right? In kinematics, we have velocity time graphs, and the area under the curve is the distance. It's the quantity, all right? Same thing. Here we have the rate at which people are coming into the venue, into the music festival, and the area under the curve is going to be the quantity. So we'll shade that region on your graph between 1 and 4 p.m. Okay, so that's D part 1. And then for D part 2, calculate the number of patrons that the model implies entered the venue. Well, how do we calculate the area? Well, it's the integral from 1 to 4 of this function, right? And you can just G-solve this straight from your calculator, right? G-solve, integral, that's your lower boundary, that's your upper boundary. Let's figure that out. Unless someone's got it already, I'll type it in. So we've got minus 0.4x plus 15 from 1 to 4. 613.5. All right, and with that we just round to the nearest figure. 614 people have come into the music festival between 1 p.m. and 4 p.m. All right, turn the page. Gets complex now. The rate dL on dt at which patrons leave the venue over 12 hours is modeled by this function. Okay, so we've got people coming in, but now we've got people going out as well. All right, so we're complicating things. On the axis of page 2, sketch a graph of dL on dt. So fortunately for us, we're already given the first graph, and for the second graph, we just need to put it in our calculator and make sure we match it up. So that's going to be 50x e to the minus 0.15x. All right, and so when we give you this question in a test, right, you have grid to sketch it on. And so, it's worth 3 marks, all right? So you get 1 mark for that sort of going through 0, 0. You'll get another mark for it intersecting in the box. Like we say it has to be in that box. You've got grid paper there, all right? So where it intersects, what have we got? An x value of 6.5-ish. So you have to have the x value of 6.5 and the corresponding y value about 122. So as long as it's in that sort of box, or even those sort of 4 boxes, because it's a pretty well on the line. If it's in one of those 4 boxes around that point, then you would get the mark there. All right. And then the last mark is to make sure it has the correct shape, and that is that it's tending downwards. Okay, that it's not sort of growing upwards forever, but that it's reaching some maximum point and then tending downwards. Okay, very good. So that's a pretty quick function, pretty quick 3 marks to get. Okay, let's move on. I'll leave that part to you. Find the time to the nearest half hour when the rate at which patrons entered the venue was the same at which they left the venue. Okay, so DE on DT describes the rate at which they're coming in. DL on DT describes the rate at which they're leaving. We're asked, when are they equal? When do they equal one another? Well, they're equal when they intersect, right? And so what's that time value? 6.449. Time is the x-axis. T is 6.449. Now we are asked, find the time to the nearest half hour. So the nearest half hour is going to be 6.5. 6.5 hours after midday. It starts at midday, 6.5 hours after midday, 6:30 p.m. Okay. All right. Given that the integral from 0 to 12 of dE on dt, take dL on dt equals 296, state the meaning of the value of 296 in the context of the problem of the number of patrons in the venue. So let's jump back to here, all right? Back here we did the integral from 1 to 4 of dE on dt, and that told us how many people entered the venue between 1 and 4 p.m. All right, so if we're asked the integral from 1 to 12 of dE on dt, take dL on dt, let's think about it like this. Split the integral, okay, from 0 to 12. What's this one tell you? How many people entered the venue in 12 hours? Okay. What's this one tell you? Well, dL on dt is the rate at which they leave. So the area under the curve tells you how many people left the venue. So we have the amount of people that came in, take away the amount of people that left, is 296. What does it mean? All right, after 12 hours, we've considered how many people have come in, we've considered how many people have left. This is how many are left over. They're the party animals. There's 296 patrons left after 12 midnight. Okay, so that's what that one means. 296 people are left in the festival after 12 midnight. So, we'll have a go at D. I'm going to put a list of questions up that I think are worth having a go at. Obviously, I recommend doing them all, but I'll focus on a few in particular so that you can really use your time effectively. And I'd encourage you to have a go at question 10 there by yourself as well. All right, that's quite a tricky one. That was the last question in the exam maybe 2 or 3 years ago. You should be able to get most of the first part, but the second part you'll have a good old wrestle with. Tricky problem. All right, so leave that with you guys. Let's get into D. I'll put a list up here on the board.